Plant power daily has its origins in agricultural practices dating back thousands of years, primarily as a way to ensure stable and sustainable food production for growing populations around the world. Ancient civilizations observed that certain plants had nutritional benefits or medicinal properties, which led to the development of agriculture. This was notably evident during the Neolithic Revolution, around 10,000 BCE, where shifts from nomadic lifestyles to settled agricultural communities began as early humans learned how to cultivate staple crops such as wheat and barley. Over time, various crop varieties were selectively bred for traits such as yield, disease resistance, or specific nutritional content. For instance, the domestication of rice in China around 10,000 BCE resulted in a significant increase in caloric intake among early Asian populations. The Green Revolution, late 20th century, brought about dramatic improvements to agricultural productivity through the introduction of high-yielding crop varieties, fertilizers, and mechanization techniques. These advancements contributed significantly to population growth, but they also had notable consequences. In many regions, monoculture farming practices have led to soil degradation and reduced biodiversity. Moreover, intensive pesticide use has resulted in environmental pollution and health issues among farmers. On the other hand, these improvements have allowed for greater food security in developing countries, contributing to declining rates of malnutrition. In terms of measurable impacts, agricultural productivity increased by approximately 30% between 1950 and 2000, resulting in a substantial reduction in hunger and undernourishment. However, this progress has not been evenly distributed. Some regions continue to struggle with food insecurity, despite global efforts to increase access to healthy diets. Looking ahead towards the year 2050, continued advancements in agricultural technology suggest even more profound changes may occur. Precision agriculture techniques could allow for optimized use of resources while minimizing environmental impacts. Additionally, biotechnology advancements might enable crops that are drought-resistant or produce higher nutritional value. However, these developments must be approached with caution to ensure sustainable food systems and equitable access. AI-informed optimization strategies could play a crucial role in future agricultural practices by predicting yield potential based on climate conditions, soil quality, and market demand, thereby guiding farmers towards more efficient resource allocation methods. This approach would support long-term sustainability goals while meeting growing global food demands effectively.